Chapter 12, Vectors and Geometry of Space. Section 12.1, Three-Dimensional Coordinate System. Okay, so we'll extend the idea of a two-dimensional coordinate system to the idea of a three-dimensional coordinate system. Now, there is some standard ways of writing the order in which we put the axes. So for a two-dimensional coordinate system, we usually do x and then y. For a three-dimensional coordinate system, well, there's some sort of arbitrariness which way we'll do it. We'll do it according to the right-hand rule. And so, after I've drawn my three axes, I'll put the ordering as follows. I'll call this the x-axis, this the y-axis, and then this the z-axis. So for most books, you'll see that we will be using the right-hand rule. So this will be the standard, well, it's not really standard, but I would say the vast majority of people write the axes in this order. So x, y, and z. Okay, so first, suppose I have 2 points in 3 space. To find the distance between them, well, it's just an extension of the distance formula for a point in the plane. So suppose I have a point P1 with coordinates x1, y1, z1. Then suppose I have a point P2 with coordinates x2, y2, z2. Then, by Pythagorean's theorem, the distance between these 2 points is just the square root of the sum of the squares of the differences between their coordinates. And so the square root of x2 minus x1 squared plus y2 minus y1 squared plus z1, or z2 doesn't really matter, z2 minus z1 squared. Okay, so suppose I have a sphere centered at the origin of radius r. Then, just like before, in the two-dimensional case, x squared plus y squared plus z squared is r squared. And suppose that the sphere of radius r is centered at the point HKL. Then the equation for the sphere would just be x minus h quantity squared plus y minus k quantity squared plus z minus l quantity squared equals r squared. Okay, so let me do an example. On page 837, in problems 17 through 20, show that the equation represents a sphere and find its center and radius. So let's do problem number 18. X squared plus y squared plus z squared plus 8x minus 6y plus 2z plus 17 equals 0. So first, let us group x's together, y's together, z's together, and let's bring the constant to the other side of my equation. And so now let's try to complete the square for each of these terms. What you do notice here is that each of these are going to be a monic quadratic trinomial. So to complete the square would be quite easy. 8 divided by 2 is 4. Four squared is 16. Let's add 16 to both sides of my equation. Let's get a little bit more, a little less space there, so I have enough room. Negative 6 divided by 2 is negative 3. Squared is 9. So let's add 9 to both sides of my equation. Two divided by 2 is 1. 1 squared is 1, so let's add 1 to both sides of my equation. And so this is equal to 9. And so the equation of my sphere is just x plus 4 squared plus y minus 3 squared plus z plus 1 squared equals 9. So the radius of the sphere is 3. And the center of my sphere is negative 4, positive 3, negative 1. And that is the radius and center for my sphere.